Hi, welcome to Algebra 2. This is Lesson A, starting on page 1 in your Saxon Algebra 2 book. We're going to do a geometry review and talk about angles, the review of absolute zero, and properties and definitions. Okay? We're going to start with some basic mathematical definitions. A point is a location. We show a point on a graph with a dot, like this, or this, or this, or this. We don't consider the size of the dot we draw. So if we are drawing a line between two dots, it doesn't matter how big the dots are. We are not going to talk about the circumference of the point or the shape of the point. They are just indicators of location. A curve is an unbroken connection of points on the path traveled by a moving point. So these are curves. This is a curve, this is a curve, and this is a curve. A mathematical line is a straight curve that has no end. Only one line can be drawn that passes through two designated points. So if we have 2 points anywhere, a line passes through both points. Actually, any 2 points. For any 2 points, there is a line that passes through it. Since a line defines the path of a moving point that has no size, we don't consider the width of a drawn line. We put arrows at the ends of lines to show that they continue in both directions. Okay? If you have a line and it has no ends, this is actually a line. If it has no arrows at the end, it's actually a line segment. So when we are talking about lines, your book sometimes doesn't draw the arrows. I would like you to draw the arrows to show that the line actually continues in both directions. Okay? We can name a line by naming any 2 points on the line in any order. So, here's a line. We can call this point A, and this point B, and this point C. The name of this line, we could call it AB, because it's the line that goes through A and B. We can call it line BA. We can call it line AC. We could call it line CA. We could call it BC. We could call it CB. Okay, any of these names is a correct name for this line because it describes the points that are on the line. A part of a line is called a line segment. A segment has 2 endpoints. Here the endpoint is A, and here the endpoint is B. It does not continue past A or B. We can call a line segment by its endpoints. So this would be either line segment A or line segment B. Notice the line on top of AB and BA does not have angles on it anymore. If we write letters without the line on top, if we say AB, we're no longer talking about the name of this line. Now we're talking about the measurement of this line. So for this all we would say line AB. This means the measure of the line. So we can say line AB is about 5 centimeters long. Okay? So this is the name of the line. This describes the width of the length of the line. A ray or a half line has one endpoint and then it continues on in the other direction. Sometimes we call this endpoint the origin. So the ray shown here starts at A, which is the origin, and goes on through B and then through C, and then continues with no end. We name a ray by naming its origin first and one of the points it goes through. So, unlike a segment or a line, for a ray it matters which letter you put first. So this ray could either be called ray AB or it could be called ray AC. Okay, and those are arrows on the top. Okay, so we've gone through points, which have no size. Now we're doing lines, which have length, but don't have width. Now we're going to talk about planes. A plane is a flat, two-dimensional surface. It has no boundaries and no thickness. So it isn't high, and it isn't thick, it just has length and width. Let's look at page 2 in your book. Okay, so right here we have pictures of 3 planes. We can consider a piece of paper a plane. It's a flat surface where we are not considering how high it is. So we have length and we have width. Okay? 2 lines on a plane may or may not intersect. If they do not intersect, they are parallel lines. So here is a plane containing 2 parallel lines. This plane is going to go on forever as the lines go on forever, but they are going to stay in the same axis. Either they're going to start like this or they're going to start like this. So as far as 3-dimensional space goes, they're going to stay pointed the same way. Okay. All points that lie on either of 2 intersecting lines are in the plane that contains the lines. Okay, so here is a plane. Here are 2 lines that intersect. Because they are intersecting, we know that they lie on the same plane. We can think of planes as stories of a house. If you're in the first floor of a house, and there are 2 lines on the floor, and you can see both lines, then they're both on the same floor. They're on the same story. They're on the same plane. If there's a line on the second floor, it may go the same direction and start in the same distance from the wall, but they're on a different plane. They're on a different surface. So they're not actually going to intersect. Okay? Just like any 2 lines, any 2 points define a line, any 2 points we can make a line that goes through them. Any 3 points we make, so if we have 3 random points, we can make intersecting lines with these 3 points. We've got a line that goes here, we've got a line that goes here, we have a line that goes here. So from those 3 points, we can make at least 2, and obviously actually 3 intersecting lines. Because these lines intersect, these lines are on the same plane. Okay, let's move on to angles. The word angle comes from the Latin angulum, which means corners. An angle is formed by 2 rays that have a common endpoint. There are different ways to define an angle, but beginning in this class and continuing through advanced math and calculus, we're going to think about rays as about angles as a rotation of a ray about its endpoint or origin. So here we have a ray starting from its origin, and here is its initial position. This is where the position it's starting from. And we're going to say that this ray is going to spin on its origin, and it's going to go counterclockwise. Okay? In Algebra 2, Advanced Math, and Calculus, we're going to be talking about unit circles. And when you get into trigonometry, you'll hear a lot more about that. But as we talk about these circles and these angles, we're always going to start with this being 0 degrees, and we're always going to move counterclockwise. You'll understand a little bit more why later. Okay, so if this ray spins on its origin to about here, so that now it's pointed this way, we're going to call this point its terminal position. Terminal means ending. Position. So this was its initial position, this is its terminal position, And this is the angle it made when it rotated on its origin. Okay? And then we could measure that angle. Okay, now we're going to talk about some special kinds of angles. We have right angles. Right angles are at 90 degrees. So here's its terminal position. It moved 90 degrees, so the lines are now perpendicular. Okay, we call that a right angle. Here we have a straight angle. So we were facing this way on its origin, and it turned all the way around, so it's now facing the exact opposite direction. We call this a straight angle, and it's at 180 degrees. Okay? An acute angle is when we start at the origin and we move up and we stop, and its terminal position is less than 90 degrees. So if the angle is less than 90 degrees, we call it an acute angle. An angle within more than 90 degrees is called an obtuse angle. If we start from here and go past 180 and continue going, so the angle is greater than 180 degrees, it's called a reflex angle. If we have a coordinate plane and we start 1 unit out, here's our initial position, and we start moving counterclockwise. Here we will be at, well, here we were at 1, 0. That was our coordinate point, right? Here we're at 0 and 1. And we have moved 90 degrees. That's a 90-degree angle. So this is 90 degrees. This is 0 degrees. If we continue moving counterclockwise till we have moved to here, now we're at -1 and 0. We've moved another 90 degrees, so this is at 180 degrees. If we continue moving, we are now at 0 and -1. We've moved another 90 degrees, and this is 270 degrees. If we continue moving clockwise, so we are back on to the original point here, we've moved another 90 degrees. So 0 is also at 360 degrees. Okay? This is a unit circle. You're going to be talking about this a lot in trigonometry when we get to advanced math and also in calculus. Okay, we can name angles by a single letter which describes its origin. So here's an angle. Its origin is called A, so we can call this angle A. If more than 2 rays are involved, we will name the angle with 3 letters. The origin, which is also called a vertex when we're talking about angles, of the angles is always the middle letter. So the name of this triangle, the big one here, is triangle BAD or triangle DAB. But the A is always in the center. This triangle is BAC or CAB. This one is CAD or DAC. Angle BAC and angle CAD are next to each other, so they're called adjacent angles. Adjacent just means next to. So BAC is next to CAD, so they are adjacent angles. Adjacent angles. Okay? Complementary angles. If the sum of 2 angles is 90 degrees, the angles are called complementary angles. So here we have a right angle, and it's been broken up into 2 angles. Here's angle B and angle A. If you add the degrees of angle B and the degrees of angle A, they are going to equal 90 degrees. because together they form a 90-degree angle. So they're called complementary angles. If the sum of two angles is 180 degrees, they're called supplementary angles. So here's something to remember. You're going to run into this a lot. If you have a straight angle and it's been broken up into two, if you know the angle of this one, it could be about 35 degrees. If you know the angle of this one, you can find the angle of this one because they're going to add up to 180. This is going to come up a lot, so look for those. Two intersecting lines. In this book, we're going to assume that all lines that look straight are straight. And in the case of my drawings, you're just going to assume they're straight unless I tell you otherwise. They're very rarely actually going to be straight because I am a terrible artist. Okay, anyway, so two intersecting lines form four angles. Here's angle A, here's angle B, C, and D. Okay? The lines opposite each other are called vertical angles. So angle A and angle C are vertical angles, and angle B and angle D are also called vertical angles because they are across from each other where two lines intersect. Vertical angles are always equal. So angle A equals angle C. Angle A equals angle C. Angle B equals angle D. Angle B equals angle D. Notice these are called tick marks. And when you see tick marks, if it's the same number of tick marks, you can assume that those angles are equal. So angle A equals angle C, and angle B, I put two tick marks here. So they are not equal to these two angles, but they are equal to each other. So angle B equals angle D. Okay, here's an example. We're going to need page number 4, where we find this figure right here. Okay, we need to find X and we need to find Y. Okay, we can see this angle is 30 degrees and this angle is 40 degrees. And notice that this angle plus X makes a right angle, and this angle plus Y makes a straight angle. So X and the 30-degree angles are complementary angles, and Y and the 40-degree angle is a supplementary angle. We can use that to find X and Y. So we know that X and the 30-degree angle are complementary. That means that X plus 30 degrees equals 90 degrees, which means we can subtract 30 from both sides and find that X equals 60 degrees. Okay, we can do the same thing with Y and the 40-degree angle. Y plus the 40-degree angle equals 180 degrees because they are supplementary angles. We're going to subtract 40 from both sides, and Y equals 140 degrees. Okay, here's another one. Still on page 4. Here we go. We have two intersecting lines, and we're supposed to find X, Y, and P. Well, the first thing we notice is that X and the 50-degree angles are opposite, and Y and the P angles are opposite. Also, if you look sideways, we'll notice that the 50-degree angle and the Y-degree angle are supplementary. This plus this equals a straight angle, and X plus P is also going to equal a straight angle. Okay? These are the kind of things we're going to be looking for. So we can say that Y plus 50 equals 180. And when we subtract 50 from both sides, Y equals 130 degrees. We can see on the picture that Y and angle P are opposite angles, so P is also going to be 130 degrees. Okay? And X and the 50-degree angle are opposite angles, so X is also going to be 50 degrees. And we can check that because angle X and angle P are also straight angles, or supplementary angles rather, so 130 plus 50 should equal 180, and they do. Okay? Alright, let's try another one. We have example A3, still on page 4. Once again, two intersecting lines. The opposite angles are going to be the 110 and the 5x degrees, and P and 2y degrees. We can also see that P and 110 are supplementary angles, and 2y and 5x are supplementary angles. Okay, also P and 5x are supplementary, and 110 and 2y are supplementary. So there are various ways we can do this. Let's start with making these two equal and then work our way around. So we said that P and the 5x and the 110 degree angles are equal. So 5x equals 110. We can solve for x by dividing both sides by 5. And x is going to equal 22. P and 110 are supplementary angles, so that means 110 plus P equals 180. We can subtract both sides by 110. And P equals 70 degrees. Okay? And now we can see that 110 and 2y are also supplementary. So 110 plus 2y equals 180. Subtract 110 from both sides. And we have 2y equals 70. Divide 2 from both sides, and y equals 35. Okay? So here's y, p, and x. Okay, we're going to switch gears a little bit and do a review on absolute zero. A number shows value. A numerical expression can be a single number or any number of terms that together describe a value. The value of all these numerical expressions is 3. So 3 equals 3. 7 plus 8 divided by 5 equals 3. 2 plus 1 equals 3. 12 divided by 4 equals 3. 75 divided by 25 equals 3. And 16 divided by 2 minus 5 equals 3. So all of these numerical expressions equal 3. A positive number is either designated by a plus sign or by a numeral without a sign. So this is positive 3. This is also positive 3. The number 0 is neither positive nor negative. Every other real number other than 0 is either positive or negative. So we can have negative 3 or we can have positive 3. The signs of the numbers are different, but the numerical part of both is 3. This part is the absolute value of the number. It's difficult to define absolute value. The best we're going to do right now is to say that the absolute value is the distance between 2 points without respect to direction. Later this year we're going to talk a little bit about vectors and directions so you'll understand the direction part better. But for now, let's think of a number line. We have, here's 3 and here's negative 3. From 0, there are 3 spaces between 0 and negative 3. There are also 3 spaces between 0 and positive 3. So the distance here is 3. The distance here is also 3, even though we're talking about negative 3. So we can say that the absolute value of 3, or the distance it is from 0, equals 3. The absolute value of negative 3, the distance it is from 0, is also 3. Okay? The written, let me change the picture. The more formal written definition of absolute 0 looks like this. If x is greater than 0, then the absolute value of x equals x. If x equals 0, then the absolute value of x equals x. If x is less than 0, then the absolute value is the opposite of x. In this case, this negative doesn't mean negative x, it means the opposite of x. So, if x was already a negative number, it's less than 0, then we can say the square root, we can say the absolute value of negative 15 is the opposite of negative 15. And the opposite of negative 15 is positive 15. Okay, let me go over that again. So the absolute value of negative 15, the distance it is from y, is the opposite of negative 15. And the opposite of negative 15 is positive 15. Okay? So if x is less than 0, then we're talking about the number's opposite. So here's a couple examples. If x plus 2 is less than 0, then we can say that the absolute value of x plus 2 equals the opposite of x plus 2. If x equals negative 5, then we can substitute the negative 5 in here, and we get the absolute value of negative 5 plus 2 equals the opposite of negative 5 plus 2. And then we distribute the negative, and we get negative, well, we can add these together and get negative 3. And now we have the opposite of negative 3, which is positive 3. Okay? Let's do another one. We have minus the absolute value of negative 4 minus 2 plus the absolute value of negative 5. Alright, let's leave this negative. Don't lose the negative out in front. The absolute value of negative 4 is going to be the opposite of negative 4. So we're going to say the opposite of negative 4. Okay? Minus 2 plus the absolute value of negative 5 is going to be the opposite of negative 5. Oops. Okay? That's ugly but correct. Here, we'll put another bracket that'll make it help. Okay, so we've got the opposite of negative 4, and a minus cancel each other out, but then there's still this negative out here. So this becomes negative 4 because of this negative. Inside here it was now positive 4. So negative 4 minus 2, and here we have two negatives, so they cancel each other out, so plus 5. Negative 4 minus 2 is negative 6, plus 5 is negative 1. Okay? Okay, let's move on. We'll be doing a lot of these. So if you don't quite understand it now, and of course it is a review, but if you don't quite understand it now, you will get it. Okay, properties and definitions. Understanding algebra is easier if we understand the difference between properties and definitions. A property defines the way something is. We can't change properties. So we have 2 plus 3 equals 5. And 3 plus 2 equals 5. The order in addition does not change the value. This is the commutative property of addition. That's not something some mathematicians made up. They gave it a name, but it remains the same, that if you count 3 first and then 2, it equals 5, and if you count 2 first and then 3, it still equals 5. So that's a property. Definitions are things that mathematicians have agreed on. For example, 3 squared equals 3 times 3. It could have meant 3 times 2. But some mathematicians some time ago got together and decided to call 3 squared and have it mean 3 times 3. The order of operations is also a definition. If we have 3 plus 4 times 5, the value of this could be 35 if we add 3 plus 4 and then times 5. That would be 35. Or if we do 4 times 5 is 20 plus 3, it equals 23. So the value of this is different depending on which order you do the operations in. So the order of operations is a definition. It's some mathematicians got together and decided that multiplication should be done before addition. So we do this part first and then we do that part. So this equals 23 and not 35. Okay, here are a few more definitions. Negative 3 squared actually means the opposite of 3 squared. There is an understood parenthesis here. So we are going to do the 3 squared first and then the negative. So this is going to equal negative 9. Okay? But if we say negative 3 squared, now the square includes the negative. So this is negative 3 times negative 3, which equals positive 9. Okay? So if there are no parentheses or if the negative is outside the parenthesis, you're going to square this value and then take the opposite of it. If there is a parenthesis and the square is outside the parenthesis like this, then the negative is included and it's going to be the 9 and not the negative 9. Alright, so let's try an example of this. Simplify. We have negative 2 cubed minus 2 squared minus negative 2 squared. Okay? The parenthesis includes the negative here, so this is going to be negative 2 cubed, which is negative 2 times negative 2 times negative 2, which equals negative 8, minus 2 squared. So the negative is still here. It's going to be the opposite of 2 squared, which is 4. Minus, this negative is inside the parenthesis. So before we distribute this, we need to take care of the exponent. So negative 2 squared is positive 4. So this is minus 4. So now we have negative 8 minus 4, which is going to equal negative 16. Okay, that is it for this lesson. Try the homework. Let me know if you have any questions. You can always email me or text me. And that's it. Thank you very much.